Hello and welcome to part 16 of the series on how to create a chess game with ReactJS. In this part we are going to work on the movement of the rook. To get started, we want to move this horse, which is in the middle of the screen, back to its original position. We are going to do that in our constants right here, where we have the layout of the board. So right here we have our rook, knight, and as you can see this knight is on x3, y3, and we should actually only put it at x01 and y017. So this should be 1, 7. Let's save it up, refresh the page, and if all is correct, yes, the knight is back. So now we are going to put a rook in the middle. So let's put this rook on the upper left corner right here. It should be 0, 1, 2, 3, 0, 1, 2, 3, 4. So that's 3, 4, 3, 4. Save it up, refresh the page, and the rook is in the correct position. Let's get our logging ready, and right now we should see our moving horizontally, vertically, and vertically. Nice. So why do we want to move the rook in the middle? So we can more easily move the rook around, because as you might have noticed, the rook is in the corner of the board, and that is not exactly the best position to move from, because it's immediately being blocked by other pieces. The first thing that we are going to do is we are going to work on the horizontal movement. If we want to move our rook to here, we should be able to do that because there is no piece blocking its way. Let's open up our referee right here, close the constants, and right here we have our rook, and right here we have moving horizontally. If we move horizontally and we have arrived at the designated or the destination, we want to console log arrived, and we actually want to return true. Let's save it up, refresh the page, and now if we move to here, we can actually move to here. So as you can see, we already have the movement for horizontal down, but what if we have a pawn? Well, it actually should be blocking its path, and it should not be able to move over the pawn. We're going to do this the same way as we did with the bishop. If you want to try this out yourself, you can pause the video and check back in a second. For the bishop, we have right here, for example, the top left movement. We check if our tile is the destination tile, and if it is not the destination tile, we check if the tile is occupied. So right here, we have to check if our tile is the destination tile, and if the tile is not the destination tile, let's log passing by. If we execute this, we should see passing by the number of times we are passing by a tile, which will be 2 times. Yes, and right now 3 times, and right now 1 time. Nice. So now we have an if statement, and in this if statement we can put all the logic for the tiles that we are passing by. And the logic that we want to put in here is the same as for the bishop, which is if tile is occupied, then we want to break. If this tile is occupied, and then we want to pass in the pass position and the board state. If it is occupied, then we want to break. Let's save it up and refresh the page. Move a pawn to here, and let's move to here. We cannot. Nice. So now we know our breaking is working, and we are not being able to walk over pawns. Let's try the same for the white pawn right here. We can also not move over it. But what if we move on top of a piece? For example, if we move the rook onto there. You see that we can just move onto there without actually any hesitation. The rook just takes up all the space. It's okay, but it's not what we want. What we want is that we want to check if the tile is occupied by an opponent. Then we want to return true. If it is not occupied, then, well, we'll just get into the else statement and it will just break off the function. Right here, we have if the position is the destination position. Then we want to check if this tile is empty or occupied by opponent. The pass position, the board state, and our own team. Then we want to return true and else we actually don't want to do anything. We are going to remove the arrived log. Let's save it up and refresh the page. If we move a pawn down to here, move over it, it's not working. Move onto it, it's not working. What if we move a pawn to here, move over it, it's not working. Move onto it, it is working. Why? Because it's an enemy pawn. Nice. So now we can actually move horizontally with our rook. Next step is vertically. So we can use the same logic as we do for the horizontal movement for the vertical movement. And we also have the attacking logic included with that. So right here we want to check if the tile is occupied or empty. We want to remove this, not this, yes. If this tile is empty or occupied by opponent, and then we want to pass in the pass position, the board state and the team. Then we return true, and then we have an else, and then here we say if this tile is occupied, pass position, board state, break. Let's save this up, open up our web page, and try to move vertically. Well, not working, not working. Can we move over it? Also not. Can we move over you? No. Can we move onto you? Yes. Nice. So, as you can see right now, we have the movement and the attacking logic for the rook down. As you can see, it's very similar to the bishop, but it's just a little bit different. Instead of diagonally, it's vertically and horizontally. But thanks to the code for the bishop, we could reuse it and reuse the idea for the movement and attacking for the bishop. Before we are going to end this video, we are going to refactor the code so we can improve it a little bit. We are going to open up our code. Inside of our code, we are going to modify the referee. Right here, we have the isValidMove. And this function, the isValidMove function, is the biggest function of the whole class of the referee. It's starting from line 77 and is going down to line 277, which is 200 lines of code. That's a lot. We are going to shrink this down, or well, not actually shrink it down. We are going to split it up into smaller functions so it will be more readable. If you want, you can pause the video and come up with a solution yourself. The solution that we are going to implement is using a switch case where we are going to switch the piece type and then we are going to execute a function according to which piece type is present. So right here we have switch and then we will switch between the type, and then we will have a case, and the case is, for example, piece type dot pawn, and in this case we will execute a function. For now, let's just console log pawn. Then we want to break this case, and we go on to the next case. Case piece type dot. Then we have our knight. Console.log knight. Break it and go to the next one. Case piece type dot bishop. Console.log bishop. Break it, not before, oh, break it, and the last one, case piece type dot rook, for now at least. Console.log rook, and we break it. Actually, for the last case we don't need to break it, since if we go to this case it will automatically just stop the switch, so we can remove break from here. Let's save it up and see if our switch case is working. We're going to grab this rook, put it here. We see rook, we see pawn, bishop, knight, and well, again rook. Nice. Next thing we're going to do is we are going to, instead of log something, we are going to call some functions. First function will be pawn move. This function will accept the same parameters as here, except for the piece type parameter, since we already know that it will be a pawn move. We have an initial position of position, desired position of position, a theme of theme type, and then at last we have a board state, which will be a piece array, like so. Next we are going to call this pawn move, this.pawn move, and we will pass in the initial position, desired position, theme, and the board state, like so. Next we are going to grab this if statement, which ends right here. We're going to remove the else from here, and we are going to grab everything that's in here, and we are going to put it right here. We can remove the if statement around it, because we already know that the piece type will be a pawn. We can remove this curly bracket right here, and if we save this up and refresh the page, our pawn logic should still be working. As you can see, it is not working. Well, and why is that? Let's see. We return something in our pawn move. We return a boolean. Okay, so that means that this is not a void. This means that this is a boolean. So let's create a bool. Boolean. Boolean. We actually need to keep this boolean. Let's read what the error says. Function lacks ending return statement and return type does not include undefined. Okay, so basically what it says is that we always need to return something. Let's add in the end a return false for when nothing will be returned. We see that the error is gone, and we see that right here we still have an error, cannot find return this. Let's see, we do want to return something. We want to return a boolean. So I don't think that the return will work in the switch type, because it would return out of the switch statement but not out of the function above it. One simple solution for this will be creating a boolean. For example, let valid move equals false, and right here valid move equals that, and right here we just at the end return valid move, like so. So now the pawn movement should work again. Let's test it out. Yes, it does. Nice, that's good, but all the other movements are, I hope, disabled. Yes, because we haven't implemented them yet. So let's start with the next one, the knight. We are going to create a knight move. We're going to copy over this piece of code right here. And instead of naming it pawn move, we are going to say knight move. We're going to close it off right here. We are going to grab this, put it here, knight move, and then here we have if type is knight. Let's grab it until we get the bishop until here, and let's put it inside of our knight move function, like so. We don't need to check for the type anymore, since the function is a type. We can remove this bracket, and then we need to return a default value, which will be false. Let's save it up and try if we can move with the knight. We still have a warning, unreachable code. Well, that's for this one, for the bishop and the rook. That's okay. Refresh the page and we can again move with the knight. Next up, we're going to do the same for the bishop and the rook. So right here we have our bishop. We're going to say valid move is equal to this dot bishop move. We want to copy paste this bishop move, and then right here we want to copy over all the logic, like so. We want to put it right here, and we want to remove the if type equals bishop. We can also remove the logging, remove the extra bracket, and then we can return false by default. Last but not least, we have our Rook. We want to say valid mode equals Rook. And I just noticed that it is valid mode and not valid move, which is a little mistake. Let's replace it everywhere with Ctrl D. So if you select one word to Ctrl D, you can select the next word which is equal to this word. It's for Visual Studio Code, so if you would like to know how to use it, Ctrl D is the solution. Right here we say this.RookMove, that's correct, and we want to create a function for it. So we copy over the bishop move, and we're going to call it RookMove. And then we are going to copy over this logic, which is inside of here. Over to up here. And then we return false by default, and we want to break out of the type. Let's save it up, refresh the page, and if all is working correctly, we should be able to move with the Rook again. Yes, and as you can see, it's still working correctly. And what we did right now is we have separated the code for the isValidMove into different functions. So instead of having one big switch statement with all the logic inside of it, we now refer to different functions. It doesn't matter that much, but for me personally, I think this makes the code more readable. And if you want to add another piece type, you can easily add another case to it and then create a separate function for it. And that function is purely for that piece type. And you don't have to add a lot of logic or remove a lot of logic from the isValidMove function. And by doing that, the isValidMove function will hopefully stay more clear and will not contain bugs. To finish it off, I'm going to fix the spacings for every function. So I'll be right back in a second. Now that we have refactored the code and we have fixed the spacings, we can open it up one more time and check if everything is working. Let's move every piece and see if we can still, yes, we can still do something. Yes, nice. Okay, so one last thing is we want to move the Rook back to the upper left corner. Before you forget that, we want to give it a Y of 7 and a X of 0. Like so. Refresh the page and we are done. I want to thank you for watching. I hope you could follow along. Leave a like, comment down below, subscribe, and I'll see you in the next episode. Bye!